The answer to whether a 14 American wire gauge ground wire can be attached to a box for a 20 amp branch circuit is no. This is because the size of the equipment grounding conductor, often referred to as the ground wire, must be appropriately sized according to the overcurrent protection device, such as a circuit breaker or fuse, protecting the circuit. The National Electrical Code, or NEC, specifically Table 250.122, dictates the minimum size requirements for equipment grounding conductors based on the rating of the overcurrent protective device. For a 20 amp overcurrent device, the NEC typically requires a minimum of 12 American wire gauge copper conductor for the equipment grounding conductor. Using a 14 American wire gauge conductor in this scenario violates this code requirement and poses a potential safety hazard. The primary function of the equipment grounding conductor is to provide a low impedance path for fault current to return to the source. This low impedance path facilitates the rapid tripping of the overcurrent device in the event of a ground fault. A ground fault occurs when an ungrounded, or hot, conductor comes into contact with the grounded metal part, such as the metal enclosure of an appliance or a metal junction box. When a ground fault occurs, a large amount of current flows through the equipment grounding conductor back to the source. This high current causes the overcurrent device to trip, interrupting the circuit and preventing electrical shock or fire. If the equipment grounding conductor is undersized, as in the case of using a 14 American wire gauge conductor on a 20 amp circuit, it may not be able to safely handle the fault current. The undersized conductor could overheat, potentially melting the insulation and creating a fire hazard. Furthermore, the increased impedance of the undersized conductor may prevent the overcurrent device from tripping quickly enough, increasing the duration of the fault and the risk of electrical shock. In addition to safety considerations, using the correct size equipment grounding conductor is essential for ensuring the proper operation of electrical equipment. Many electronic devices are sensitive to voltage fluctuations and electrical noise. A properly sized equipment grounding conductor helps to minimize these disturbances by providing a stable and low impedance reference point for the circuit. This improves the performance and reliability of the equipment. The NEC provides specific guidelines for installing equipment grounding conductors. Firstly, the equipment grounding conductor must be connected to the grounding electrode system of the service equipment. This connection provides a direct path to ground, ensuring that any fault current will be safely dissipated. Secondly, the equipment grounding conductor must be installed in the same raceway or cable as the circuit conductors. This minimizes the impedance of the grounding path and ensures that the overcurrent device will trip quickly in the event of a fault. Thirdly, the equipment grounding conductor must be securely connected to all metal enclosures and equipment that are part of the circuit. This ensures that all exposed metal parts are effectively grounded, reducing the risk of electrical shock. There are a few exceptions to the general rule that the equipment grounding conductor must be sized according to Table 250.122 of the NEC. One exception applies to certain types of flexible metal conduit. If the flexible metal conduit is installed with fittings that are listed for grounding, it can be used as the equipment grounding conductor, even if its size is smaller than what is required by Table 250.122. However, this exception is subject to certain limitations and restrictions. Another exception applies to certain types of cable assemblies. If the cable assembly contains an equipment grounding conductor that is specifically designed for grounding purposes, it can be used as the equipment grounding conductor, even if its size is smaller than what is required by Table 250.122. However, this exception is also subject to certain limitations and restrictions. It is important to note that these exceptions should only be applied by qualified electrical professionals who are familiar with the NEC and the specific requirements of the installation. Improperly applying these exceptions could result in a safety hazard. In summary, a 14 American wire gauge ground wire should not be used on a 20 amp branch circuit because it violates the minimum size requirements for equipment grounding conductors as specified in the National Electrical Code. Using an undersized ground wire can compromise safety by increasing the risk of fire and electrical shock. Always refer to the NEC and consult with a qualified electrician to ensure that all electrical wiring is installed in accordance with the applicable codes and standards. Failing to adhere to these regulations can have serious consequences, including property damage, injury, or even death. Therefore, it is essential to prioritize safety and ensure that all electrical work is performed by competent and knowledgeable individuals. The correct size of the equipment grounding conductor is paramount for the safe and reliable operation of any electrical system. Therefore, strict adherence to the NEC and other relevant standards is crucial for maintaining electrical safety and preventing potential hazards. For a 20-amp circuit, the general rule is to use a 12 American wire gauge copper wire or an equivalent size if using a different material. This ensures that the ground wire can safely carry fault current back to the source and facilitate the tripping of the overcurrent protective device in the event of a ground fault. Always check local codes and regulations as they may have additional requirements or restrictions. Always consult the most recent edition of the National Electrical Code for the most up-to-date information and requirements. The electrical codes and standards are constantly evolving to address new technologies and safety concerns. Staying informed about these changes is essential for ensuring that all electrical work is performed safely and in compliance with the latest regulations. Proper grounding is a critical aspect of electrical safety. It is important to understand the principles of grounding and the requirements of the NEC to ensure that electrical systems are installed and maintained in a safe and reliable manner. The equipment grounding conductor plays a vital role in protecting people and property from electrical hazards. Using the correct size equipment grounding conductor is essential for minimizing the risk of electrical shock, fire, and equipment damage. Always consult with a qualified electrician if you have any questions or concerns about grounding or any other aspect of electrical wiring. A qualified electrician has the knowledge and experience to ensure that all electrical work is performed safely and in compliance with the applicable codes and standards. Remember, electrical work can be dangerous and should only be performed by qualified individuals. Never attempt to perform electrical work if you are not properly trained and equipped. Prioritize safety and always follow the applicable codes and standards to protect yourself and others from electrical hazards. In addition to the equipment grounding conductor, the grounding electrode system is another important component of the overall grounding system. The grounding electrode system provides a connection to earth, which helps to stabilize the voltage of the electrical system and provides a path for fault current to dissipate. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal underground water pipes. The grounding electrodes must be properly installed and connected to the electrical system to ensure that they are effective. The NEC provides specific requirements for the installation and connection of grounding electrodes. It is important to follow these requirements to ensure that the grounding electrode system is properly installed and will function as intended. The grounding electrode system should be inspected periodically to ensure that it is in good condition. Ground rods can corrode over time, which can reduce their effectiveness. If the grounding electrodes are found to be corroded or damaged, they should be replaced. Proper grounding is essential for protecting people and property from electrical hazards. By following the requirements of the NEC and consulting with a qualified electrician, you can ensure that your electrical system is properly grounded and safe. It is also important to note that the size of the equipment grounding conductor may need to be increased if the circuit conductors are upsized for voltage drop. Voltage drop occurs when the voltage at the end of a long circuit is lower than the voltage at the source. This can cause equipment to malfunction or operate inefficiently. To compensate for voltage drop, the circuit conductors may need to be upsized. If the circuit conductors are upsized, the equipment grounding conductor must also be upsized to maintain the proper grounding impedance. The NEC provides guidance on how to size the equipment grounding conductor when the circuit conductors are upsized for voltage drop. Always consult the NEC and a qualified electrician to ensure that the equipment grounding conductor is properly sized. Also, consider that using aluminum conductors requires different sizing than copper conductors. Aluminum has a higher resistance than copper, so aluminum conductors must be larger than copper conductors to carry the same amount of current. If using aluminum conductors for a 20 amp circuit, the equipment grounding conductor must also be sized accordingly. Always consult the NEC and a qualified electrician to ensure that the equipment grounding conductor is properly sized for the type of conductor being used. In conclusion, never use a 14 American wire gauge ground wire on a 20 amp circuit. Always follow the NEC and consult with a qualified electrician to ensure that your electrical system is safe and compliant with all applicable codes and standards.